Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient. It'll just be the one that I come up with first as I'm working through the problem here. So this is another medium. Hopefully this one doesn't take too long like some of the others that I've done earlier possibly have. So this one is number 11 on the website, container with most water. So it says you are given an integer array height of length n. Okay, so that's this int array, where there are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So they show their example here where these are the heights. The output is 49, and it's going to be between these two. And this is an important example because it shows that it's not necessarily just finding the two highest ones, because this is actually more because of the width. So explanation. So the above vertical lines are represented by this array. In this case, the max area of water, the blue section, the container can contain is 49. So if you had these two, it was 8 and the 7 at the end. So the 7 is the height, because you think about this as a rectangle. The 7 is the height, because they can't go up to the 8. And the width is 1, 2, 3, 4, 5, 6, 7. So it's 7 times 7, which is 49. Okay, gotcha. So that makes sense. So each width is just considered 1, and then each height's considered 1. And then example 2 here, you have just 1 and 1. The output is 1, because in that case, there's one width and the highest height is 1, so it's 1 times 1. Okay. So n is going to be equal to height.length. N is going to be between 2 and 100,000. And then height of I is going to be between 0 and 10,000. So I think the kind of straightforward approach that I'm going to try is to go with just kind of comparing them and seeing, going through each one and then like starting with this one and comparing it with this one all the way through the end, and doing the quick calculation of the width times the height, and just record the highest one before you exit, and then you can kind of loop through all of those. Now, we'll see how it goes. There's a possibility that if there's 100,000 that it'll time out because it'll take too long, but we'll see how that goes. So we'll go ahead and copy this over here, and we will start working on this. So we're definitely going to need to have a result that's going to be equal to 0 initially. We're going to return the result at the end, and this is going to be a var. We're going to say for first column in height. Oops. And we are going to need the index. We'll call this outer index. And we'll do index. And then you're going to do for inner index. We'll just do second column in height dot width index. So if first thing we want to do at the start of this is if the inner index is less than outer index, continue, right? Because we only want the second index to be after the outer index. So if it's less than or if it's equal to, then continue. And we'll see later if we get any issues. See, because the height can be 0, and I assume that they would want 0 returned, so this should work. But if they want something else returned, we'll see it in the errors, and we'll fix it then when the tests are run. So what we're going to do in here, we'll make a separate function here that's going to say calculate area. We'll have a width and a height, and it's just going to return width times height. We want it to return an integer. and we can make this private. And you're just going to say if, we're going to say val area is equal to calculate area. And so the width of this is going to be inner index. Let me think about this. So if it's going to be 2 and 1, yeah. So we'll do the inner index. It's going to be the second one. Oops. Inner index minus outer index for the width. And the height is going to be, is there a max function? Yeah, there is. Max, and it's going to be a max of 2 ints. And they should have that in here. So we can just say max. Actually, it's min. You want the smaller of the two, so we'll just import min. So the min, and it's going to be between first column and second column. Say if area is greater than results, result is equal to area. After you go through all these loops here, you return that result. Now, I'll be surprised if this works as a solution. It's probably going to tell me that this is not efficient enough, but I'll go ahead and try it out. This seems like a very simple solution, considering this is a medium difficulty problem. So let's run it on the example. So that got accepted, but like I said, I wouldn't be too surprised if it told me this was too slow on the example with 100,000. But we'll see how this goes here. Yeah, see, time limit exceeded when there is a very long one. So yeah, this is a very long answer. All right, so I thought of an improvement that I could make. So basically what I'm going to try to do, at every single instance that we get to, whenever we get to a new outer index here, we're going to decide whether or not we should do these inner comparisons at all. Basically, so like, let's take this example here. So if we were at here, so we already went through comparing all the values that start with this, and we found this, which ends up being the maximum, but we don't know that yet. And we get to this value. It'd be a good example, right? We get to this as being the first one. Well, we can quickly calculate out that since we always take the height to be the minimum of these two, that it's going to be no bigger, the height is going to be no bigger than this. So we could quickly calculate out that, hey, you know, we have a height of 2 here, and we know that there's only 1, 2, 3, 4, 5 values after this. So the maximum area that we could possibly get if these values are bigger is 2 times 5. And that's less than the value that we have so far. So we can just completely skip the entire inner loop for this value because it can't possibly be bigger. So that's what I'm going to be trying to calculate. So this will actually end up being slower for these small examples because we're doing extra calculations. But when we do the bigger ones, it should make it more efficient. So let's do that. So when we get to a new outer index, we're going to have max possible area. And we're going to end up assigning that later. What do we need to figure out first? So we need to figure out values left, or I should say max width. That's going to be equal to height dot size minus outer index minus 1. Right, because outer index is going to be adjusted over by 1. So if the size is 5 and we're on the second one, it's going to be 1. So we want to do 5 minus 2. So there's 3 left because it would be going from the second one to 3, 4, 5. Yeah, okay. So that's the max width. And then the max possible area, we can go ahead and get rid of this line. That's going to be equal to calculate area, max width, and the first column, which is going to be the height of this column. And then we can just say if max possible area is less than max area, actually it's results, then continue. So that's just that slight improvement here. So let's go ahead and copy this over this class, and we'll test that with their example here. So that passed, and then let's go ahead and see if that is efficient enough. It is. All right. So that really wasn't too bad. It took a little bit of thinking that I did off camera, just trying to figure out a way to improve the efficiency of the basic algorithm, but it looks like that was good enough. It does show that it's not a particularly good answer. I'm sure that if you could, spend a lot of time thinking about this, you could come up with even more ways to improve the algorithm, but this is good enough for the submission. So I just ended up implementing the basic solution and then having to make one big improvement, I think, on those large ones. So let's go ahead and go over the code real quick. So here we have our max area. We're getting our height, which is the int array of the columns, and we're returning the int, which is going to be the max area. First, we're going to set our result to 0, and it looks like that was correct. Basically, if it passes no values, then it just wants 0 as the max area. So then we're going to need an outer and an inner loop. So the outer loop, we're just going to loop from the first column. And actually, I just thought of one improvement we can make already. Obviously, if we're at the last column, we can just continue. But this would be a really fast check anyways. So we're starting at the first column, and we're going to end up going all the way through the last column with the indexes. And this is going to be outer index. This is our improvement that we had to make right here. So we're going to find what the max width is. It's going to be the size minus the current outer index minus 1, because we need to adjust because the outer index starts with 0. And so this is just finding what is the max possible width. So from the current value to the end of the int array, what is that width? And then we're going to find the max possible area. So because in our formula here, we're taking the min, when we're multiplying the width by the height, we're taking the min of the column that we're starting with and the column that we're checking against. The max possible area when we loop through checking every single value is going to be this max width multiplied by the height of this first column. It can't get any higher than this. And then we just check, is that max possible area less than the result that we have already? If it is, then just continue, skip to the next one. There's no possible way that any height or any width at this point is going to be greater. So just continue, skip it. But if that's not the case, then it's possible that it can have a bigger result. So we're going to go ahead and loop through, and basically we have our column that we're working with, and we're going to check here, is this inner index less than or equal to, are we to the left of, or are we at the same place as this first column that we're checking? If so, then just continue to the next one, because we're not checking backwards. That'd be wasting processing. So we make sure we start basically the actual inner loop when we have our column, and then the next column is after the first column. If that's the case, then we just calculate the area, which we're just passing the inner index minus the outer index to find the difference. We don't need to do any -1 adjusting because these are both indexes. Or these are both indexes, the inner and outer. And then we're going to multiply that by, once again, the minimum of the first column and the second column. And if the area is greater than result, we're just setting result to area. It's as simple as that. And then once we go through those for loops, we're just going to return the result. That's going to be the max area. And then we just have this little small function here. It's incredibly simple, just taking the width and the height, multiplying them together to return it. All right, so that's going to be it for this one. Hope that helped you guys out. Thanks for watching. Catch you guys next time.